I'm doing the first test with EDTA prepared solution. I'm making it react with copper sulfate, which is having a concentration of 0.02 molar. So I'm adding about 1 ml of the copper sulfate solution. Please note down the color. Actually, it's very, very light blue. It should be light blue because the concentration is also very, very low. To this, I'm going to add about 5 ml of the buffer solution of pH 10. The buffer solution is ammonium chloride buffer solution. I need to add about 5 ml. So I've added 2. Please see the change in color. Yes, so I've added around 5 ml. Before the color was light blue and now the color has changed to dark blue. What does it mean? Copper sulfate, which was forming a complex maybe with water, now the water ligand leaves and ammonia ligand joins with copper to form a ligand to form a complex with copper. So this is the dark blue color. Followed by, now comes the EDTA, which is also a ligand. I have to add, see the change in the color. I add EDTA drop by drop. Yes, as you can see, there is a slight change in color. Yes. So this is the formation of complex of copper with EDTA. As you can see, the color is slight blue greenish. So this shows that these are the various reactions which happen where each ligand like sulfate, ammonia, EDTA keep changing and keep forming the complex. The use of using the pH 2 buffer, students, pH 10 buffer is to keep the complex stable during the reaction. To do the second test of EDTA with ferric chloride solution, the first step is to take 1 ml of ferric chloride. See the change in color. See the color is yellow. To this, I'm going to add around 5 ml of pH 2 buffer, which is hydrochloric acid, sodium ethanoate. See the change in color again. The color was very dark yellow and now it turns very light color. So as you can see the change in color here. So now there's a complex formed since the pH 2 is hydrochloric acid, sodium ethanoate. So here the ligand is chloride and you can see there is a light yellow color. Followed by potassium thiocyanate. As you can see here, thiocyanate is also going to act as a ligand. I'm going to add in drops. As you can see, the color is getting dark and it has become a dark red color. So this is due to formation of the complex of iron with thiocyanate ligand. Again followed by EDTA. EDTA also is a ligand. I'm going to add in drops. See the change in color. So now there is a replacement of the thiocyanate ligand with EDTA and you can see the change in color. I repeat again the ligands that we had various. We started with ferric chloride. So the chloride was the ligand. We made a solution. So chloride was replaced with water, followed by we added pH 2, that is the buffer solution of pH 2, hydrochloric acid and sodium ethanoate buffer solution, where the chloride was the ligand, which was replaced from water, followed by we added ferric, I'm sorry students, we added potassium thiocyanate. So thiocyanate is a ligand which was again replaced by chloride, followed by EDTA. So this is the color that we get, light yellow. So here there is a replacement of thiocyanate with EDTA. Now I'm doing the third test of EDTA with magnesium sulfate. So I have to add 1 ml of magnesium sulfate. As you can see, the colors looks to be colorless here. The concentration also 0.02. So to this I am going to add about 5 ml of pH 10, which is again ammonium chloride solution. So I have to add about 5. See the change in color. There's a slight change, but not much change in the color, as you can see. But there is a formation of complex of of magnesium with ammonia. There is a formation of the complex, and the work of using the pH 10 over here is to keep the pH conditions constant in the reaction. Followed by, I'm going to add erythrome black tea, which also now the magnesium will form a complex with erythrome black tea. So there's a replacement of the ligands. So here I need to add in drops. So you can see there is a formation of a violet purple color with the formation. So now this is the complex of magnesium with erythrome black tea. Now again followed by EDTA, which I have to add in drops. So erythrome black tea will be replaced by the EDTA ligand. Yes, as you can see now, the color is, I can say it's blue, little dark blue. So this is the formation of the complex of magnesium with EDTA. So we started now with magnesium sulfate, again diluted with water. So there was a ligand replacement with water, followed by pH 10 with ammonia as a ligand replacement, followed by erythrome black tea replacement. Again, the magnesium forms a complex with EDTA.